In this video, we're going to be finding the domain of combined functions. In 1, it says choose the option 1 through 4 that makes each statement true. In A, we have the domain of a function is the largest set of real numbers for which the value of f of x is a real number, so number 1. In B, the domain of a square root function excludes values that make the radicand negative, so number 4. And in C, the domain of a rational function excludes the values that make the denominator equal to 0, so number 3. In 2, it says, for each statement below, choose the option 1 through 3 which results in a true statement. The domain of the function p of x is equal to x plus 2 times x minus 2 is all real numbers because we have a polynomial, so we're going to have 1, negative infinity to infinity, which means that p of x is defined for all real values of x. In B, the domain of the function r of x is equal to x minus 2 divided by x plus 2 squared is every value except for negative 2. So number 2, negative infinity to negative 2 union negative 2 to infinity. And we exclude negative 2 because the denominator is 0. When x is equal to negative 2, which means that the domain is everything except negative 2. In C, we have the domain of the function f of x is equal to x plus 1 divided by x squared minus 4 is all values except for 2 and negative 2, so number 3, or negative infinity to negative 2 union negative 2 to 2 union 2 to infinity. And the denominator is 0 when x is equal to plus or minus 2. So the domain is everything except 2 and negative 2. In 3, it says choose the option 1 through 4 which results in a true statement. In A, we have the domain of the function s of x is equal to the square root of x minus 5 is, so we have x minus 5 has to be greater than or equal to 0, and if we add 5 to both sides, we get x is greater than or equal to 5, which means our domain is 5 including 5 to infinity, so number 3. In B, we have the domain of the function r of x is equal to 1 over the square root of x minus 5 is, so because the square root of x minus 5 is in the denominator, we cannot include when the inequality is equal to 0. So we're going to have x minus 5 is strictly greater than 0. And then if we add 5 to both sides, we get x is greater than 5. So we're going to have number 1, or 5 to infinity. In 4, it says, find the domain of the following function. State the answers in interval notation. In A, we have v of x is equal to x minus 3 divided by the square root of x plus 2. And the first thing they ask are there any restrictions in the numerator? And there are not. So we say no to restrictions in the numerator. And then they ask, are there any restrictions in the denominator? If so, what are they? In our denominator, we definitely have restrictions, so yes. And we have a radical. So inside the radical has to be greater than or equal to 0. And it can't equal 0 because we're in the denominator. So we have x plus 2 has to be greater than 0. And if we subtract 2 from both sides, we get x is greater than negative 2. So now if we want to graph it on the number line, we have an open circle on negative 2 because it's not included in the domain. And then we're going to shade everywhere where x is greater than negative 2. And then in interval notation, we're going to have negative 2 to infinity. In B, we have w of x is equal to the square root of x plus 2 divided by x minus 3. And the first question asked is, are there any restrictions on the numerator? And the answer is yes, because we have a radical. And x plus 2 has to be greater than or equal to 0. And now we subtract 2 from both sides, and we get x has to be greater than or equal to negative 2. And then it asked, are there any restrictions on the denominator? If so, what are they? And there are restrictions because our denominator cannot equal 0, and it equals 0 at x is equal to 3. So x cannot equal 3. And now to graph this on the number line, we're going to go to negative 2 and put a solid dot this time because we can include that point. And because we're going to shade greater than negative 2, I'm going to put an open circle on 3 because we have to exclude that point. And now I'm going to shade from negative 2 to 3, and then from 3 to infinity. So in interval notation, we have bracket, because we can include negative 2 this time, to 3, union, 3 to infinity. In C, we have z of x is equal to the square root of x plus 2 divided by x squared minus 3x. First thing asked is, are there any restrictions on the numerator? And the answer is yes, because we have a radical. So x plus 2 has to be greater than or equal to 0, or x has to be greater than or equal to negative 2. And then it asks, are there any restrictions on the denominator? If so, what are they? And in the denominator, it cannot equal 0, so we have x squared minus 3x is equal to 0. And if I factor in x out of both terms on the left side, I have x times x minus 3 is equal to 0. So x cannot equal 0, and x cannot equal 3. So now to graph it on the number line, I'm going to go to negative 2 and put my closed dot because we can include it. And then it's everything greater than negative 2 except for 0 and 3. So I'm going to put an open circle on 0 and an open circle on 3. And now I'm going to shade everything greater than negative 2 except for where my open circles are. And in interval notation, we would have from negative 2, including negative 2, to 0, union, 0 to 3, union, 3 to infinity. And that's all for this video on finding the domain of combined functions.